Good day, folks. This is tutorial number 14, which is essentially a simplified version of tutorial 13 in the present playlist, which is named Kinematics Analysis in the 3D Experience. Now, when I did number 13, I mentioned that this gear train was going to be done with a gear joint and a rack joint, and I did it. However, we're going to come back and repeat this problem, slightly modified version of it, using two roll curves, one between the big gear and the small gear, and the other one is between the big gear and the rack. Now, these are the dimensions that I'm going to take, and just for simplicity, it's entirely up to you. However, based on this radius and that radius, I found the gear ratio. So if I assume that the small pinion, for example, turns at 180 RPM, the big gear uh, spins at 1/3 of the speed, and the rack advances by the radius of the big gear, which is 30 millimeters, by the angular velocity of it in rad per second, 188 millimeter per second. So this is how we're going to check to see whether we have done it correctly or not. Now, as I go through this tutorial, I will come across these dialog boxes that I'll talk about later on as we go through it. And remember that tutorial 13, which was the gear train, was the chapter 8 of the textbook that was written for 2016 release of 3D Experience. That's 8 years old. There are some differences in interface, icons, and some functionalities. Okay, so let's go ahead and do that. So I'm going to start with an assembly file and immediately add a 3D part, which is going to be the wall. Okay, so insert 3D part. Okay, so this is going to be the wall. Okay. All right, let me change the name of it so that's easier to keep track of things. This is going to be wall, and the instance also wall. Okay, or the base. I think in here I probably called it the base. Yeah, that's the base, but that's okay. Call it the wall. Double click on it. On that vertical plane, I will sketch a rectangle, which is 40 millimeters this way, 35 millimeters that way. So let me do this one first. So this is going to be 35. Sorry, that's going to be 40. No, this is going to be 35. And this is going to be 40. And you see why I chose these dimensions in a second. So let's go all the way to the top. Oh, I have to. Oh, sorry, I have to go and pad this thing, right? So I exited the sketcher and I'm going to pad it by 5 millimeter. Good. So this is going to be the wall or the base. Go all the way to the top. Insert a 3D part. Let me call this thing big gear. So on the properties, I'll put the prefix big. Big. Okay, let's go make it. Double click on a convenient plane. On that same plane, I will sketch a circle, radius 30 millimeters. Yeah, good. And I'll put a little circle on the very top here so that we can see when it rotates, at least we can see that it is actually rotating. Exit, and then also padded by 5 millimeters. Notice that I'm not drawing the shaft of this big gear, etc., because this is the simplified version. We go all the way to the top, right click, insert, 3D part, once again. This one I'm going to call the small gear, right click, properties, put the prefix small there. Okay, let's go make it on that same plane. For convenience, I'm going to draw a circle which is radius 10 millimeters. This is going to be a small gear. Dimension this thing to be 10. And I will also make a little circle here so that I can see the rotation of the object. Exit and pad it by 5 millimeters. Good. And finally, we're going to make the rack. So all the way to the top, right click, insert, 3D part. I'm going to call this thing the rack. All right, so make it. It's just on the vertical plane. I will sketch a rectangle which is 5 millimeters high. I'll make it maybe okay. So let's make this thing 5. Okay, 5. Exit. Yep. So padded by 5 millimeters. This is going to be our rack. Okay. So let's go ahead and assemble things all the way to the top. There are different ways of doing this. For example, I can go and create the joints directly, or I can actually create a mechanism and then go make the joint. I'll do it right here. So first of all, let's go and fix the wall. Okay, that's fixed. See that? Okay. Then I'm going to create my first revolute joint between. Okay, let's go ahead and create a revolute. The one that I want to use is uh, line and line, plane and plane. This one, that one over here. So this axis and that line, and this back plane and this plane. Okay, and for the last item, which basically controls the angle. So I'm going to select, for example, the horizontal plane of the wall and the horizontal plane of the big gear, and then we say OK. Okay, I don't want to do any contact calculation. Now I'm going to put this gear and put it on the other side. So another revolute, once again using same template. So the axis of this and that line, and the back plane of this and the plane of the wall. And again, for the angle, I'm going to use the XY plane of the wall and the XY plane of the small gear. Good. No. Okay, let's assemble the rack. So this is going to be prismatic. All right, and again, line and line, plane and plane, coincidence, that'll be this one, right? Line and line, plane and plane. So let's do that. So it's going to be this line and that line. And for example, these two planes. And for the offset, I'm using two planes. So for example, this plane and sure, that plane. We say OK. And no. And update. There we go. So basically, I have created my model, and this is what you see kind of there. Okay. Now, let me do a quick save here. So my strategy is to go to first go and create the joints in the mechanical system design. And then once I do that, then I'm going to go do the simulation. So let's go to engineer, what is that? Mechanical systems design. Okay. And let's create the mechanism. And let's check what kind of joints do we have. We should have two revolute and one prismatic. And the degree of freedom is 3. That needless to say, we can check it out. For example, if you go to the mechanism player, there's going to be 3 bars here, one for this, one for that, and one for this. Okay, so reset everything, go back. All right, now we can create the roll curves joint right now. So let's go ahead and do that, or we can do it later. So if you go to engineering connection, roll curve joint, you won't see it as a template here. See that these are for some very basic ones. Roll curve joint, you have to go to the user define, find roll curve, which is somewhere here. Okay, so what I'm going to do is the first one is going to be between this periphery of the big gear, and for the second case, the edge of the prismatic one. Okay, let's say okay, and a no, and another roll curve joint, between the periphery of the big gear and this pinion. Okay, and then we say okay, say no. Now, if you go to your mechanism manager, you see that these last two that I added, they're not included. So check that and check that. Now we say okay. Let's click on this mechanism player. What you see is these are created. These things are created. You can see that. But they're all doing the same thing. But that's fine. No problem. Okay. So what I showed you basically was this. Okay. Now what I'm going to do is I'm going to make the first one, which is the roll curve between this and the the revolute, the first revolute, which was this bigger one, angle driven. So let's go here. So we go there. These are angle driven. Now even if I uncheck these, see this? Even if I uncheck it, uncheck this one and uncheck this one, and I say okay, and I go to the mechanism player, it still works. See that? So it was unnecessary to have all of those to be checked. So this is what that thing has done. Only the one between the big gear, the revolute between the big, between the revolute between big gear and the wall is angle driven. The other one, they all say no. So that's what this. If I double click on that, you see that they all no except for the first one. Good. So now that these are created, what we're going to do is we're going to go to the mechanical system experience. We create our simulation. Okay. All right. Now, first thing is we want to specify the angular velocity of this big gear, which is 6.28 rad per second, or 60 RPM. Okay, this is 60 RPM, a third of 180 of the pinion. So 60 RPM. So what I'm going to do is, first of all, go to the law excitation, click on the law excitation, select the command. This command is for the angle of the big gear, that revolute. Click on f of x. Now here, I can just say plus. That's 0 degree. I can backspace and get rid of it. Plus 60 TURN. You can't write RPM. turn underscore min times time. Okay, now I may have to go, I may change this thing to minus depending on whether I want this thing to go to the left or to the right. That's okay, we just leave it the way it is. All right, and good. Say okay. And we create a probe here because eventually we're going to plot the velocity of some point. So this point, we're going to plot the velocity of this point, which better comes out to be 188 millimeters per second. Okay, and then we create our kinematic scenario. So excitation is going to go there, probe is going to go there, and for the time, I'm going to do it over 1 second interval. So that's what this window is about, 1 second interval with a time step of 0.05, that being 0.05. If necessary, I'm going to make the time smaller or bigger, etc. So we say okay, and now we're going to compute it. Good, we went in the direction that I wanted. Now, if you clock, first of all, you can animate this thing. Let me make this thing smaller, and we can play it so it goes forward and backward. Okay, this is a cartoon, but the physics is built into that because I specified the angular velocity of that big revolute, big gear. I did. There is physics here. Now, how do I know? We're going to check that by plotting plot results, scenario results. I want the velocity of that point, linear velocity of it, or velocity in direction y, which is going to be the same thing. I better get 188 millimeter per second. So I selected magnitude of the linear velocity, and there is your 188 right there, 188.946. And the reason it goes like that because it didn't go all the way to the end of the time period. It stopped pretty much at 0.87. So if you want, we can go and change this scenario time duration. Either make this thing longer or let me see now. Where is that scenario? Here, parameters. I can make it 0.8. Say OK and run it. Good. Then plot. Deselect everything except for the magnitude of the linear velocity and goes 188. Yeah, 188 millimeter per second. All right, folks, this is it.